Hello, everyone, and welcome to today's webinar. We will wait until all the people that are in the lobby join, and we'll start in less than a minute. All right, so welcome everyone to today's webinar. My name is Lucia, and I am the community builder here at Pasqal and your host for today's session. I'm really happy to have all of you here today as we discover how Pasqal Cloud can open opportunities for you to solve complex computational problems. When we speak about the cloud, we speak about access, easy, scalable, on-demand access to powerful computing resources. For many users, and probably for most of us today here, this means the difference between having an idea and actually being able to explore it without relying on potentially limited high performance computing allocations or maintaining your own infrastructure. However, today's challenge do require this type of flexibility in terms of access. These challenges could be, for example, simulating the behavior of extremely complex systems to enlarging already existing utility network infrastructures. All these are extremely resource-intensive challenges where classical methods can struggle to scale, where, however, hybrid and quantum resources like those available in Pasqal Cloud, as we will see in a bit, can allow you to experiment and keep innovating. So for users who do not have access to high-performance computing clusters, or those who do have access to these type of clusters, but whose workload already hit the classical limits, Pasqal Cloud becomes the true test bed for innovation, where you can start using maybe for the first time neutral atom quantum computing resources. You can experiment freely with hybrid and quantum algorithms and start to build your own application portfolio for your organization or for your research. So if you are excited as I am to learn more about the cloud, please welcome together with me the experts of today. So thank you guys for being with us today. Baptiste Peira is the product manager of the cloud platform, and Mathieu Muro is the engineering manager of the cloud platform. Thanks for being here with us today. So before we dive into the topic of today, let me just share a quick note with you. If you have questions throughout the webinar, please make sure to share them in the questions features that you can find on the bottom right side of your screen right now. And you can share them throughout the webinar. We will get to the questions in 2 moments, one at the end of the part that Baptiste will lead in the middle of the webinar, and one at the end of the webinar after Mathieu's contribution. So make sure to share them in the questions features. And now, with no further ado, we start our session of today with a poll question. So you will see the poll popping up on your screen. If your quantum knowledge were measured in qubits, how powerful would it be? Let's see. How do you see yourself? I want to see how many 100 plus qubits we have here and how many one we have. It's the webinar is for everyone. You will see that we make quantum computing as accessible as possible. All right, I see that there are quite few 5 qubits. The majority is actually 5 qubits, but quite a flat distribution. So good to see that. All right, perfect. Then I guess it's your turn, Baptiste. Please, join me on the stage.
Yes. Hello, everyone, and welcome, and thank you for being here today for this Cloud webinar. So I will begin with a quick presentation of Pasqal, and then I will dive into what is Pasqal Cloud and why we're building our quantum computing as a service product. So eager to start. So first, a little presentation of Pasqal. Some of you may know us, but we are a quantum computing company, and our goal is to build the most advanced fault-tolerant quantum computer. So we are building those quantum processing units that we call QPUs via 2 factories today. One is in the Paris area, and the other one is in Canada. We are really committed to delivering concrete application thanks to quantum computers. That's why we are collaborating with leading tech giants and industry pioneers that will have, hopefully in the next few years, real business value thanks to our computers. But you may ask, why should people be interested in quantum computers right now? Well, at Pasqal, we believe that quantum computers will outperform classical computers on specific tasks, such as material simulation, machine learning problems, or even optimizations in the next few years. But today, it is already providing some value. And if you want to be ready for what's coming soon, the good moment to get into quantum is now. So let me tell you a little bit about our technology first. So we are building and delivering neutral atom quantum computers. And as of today, we are the market leader in delivering those. There are several advantages about the neutral atom technology. And for this tech, qubits are atoms. In our case, it's even rubidium atoms. And it's a huge advantage for several reasons, but the main one are really the scalability that it offers, the fact that it's super reliable and it has high connectivity in between the qubits. It also operates at room temperature, which is a huge thing for us, and with a very low energy consumption. Let's talk about our approach. So Pasqal really have a full stack approach to operate the technology. So the first one is the application layer. We have use case experts that can translate your industrial challenge into a mathematical problem that can be implemented directly on our quantum device. To implement this problem, we build a clear and efficient software stack that will translate into instructions for our third layer that we build, which is the real hardware, the real neutral atom quantum computer that we'll develop fully in-house. So this hardware is available on-premise for those wanting to buy a QPU, or directly in the cloud, and that's where the quantum computing as a service product comes into play. We make our state-of-the-art hardware available on this cloud so our client can access our quantum resources easily, with flexibility and without any upfront costs. So let's dive into why we are building this quantum computing as a service product. So as you know, and that's why you're here, more and more people are eager to explore quantum computing, but gaining experience can require substantial investments in hardware and infrastructure. But Pasqal Cloud changes that by bringing neutral atom quantum computing directly to your fingertip. Through the Pasqal Cloud platform, users can experiment with real quantum hardware without needing to manage a full-scale QPU. So everything is available within a simple and streamlined workflow. This approach allows researchers, developers, and even just early innovators to start running quantum experiments immediately and to unlock the potential of quantum technology in a practical and accessible way. This is why quantum computing as a service that we call QCaaS truly shines, because with just a click, you gain remote access to one of our QPUs or emulators, enabling you to execute quantum jobs directly. It's a fully managed experience that eliminates traditional barriers to entry and lets users really focus on experimentation, algorithm development, and problem solving itself. By leveraging this quantum computing as a service product, organization can turn what once felt like a distant and experimental technology into a tangible and actionable tool. So that's why we're building it. Now, what is Pasqal Cloud? So on one side, you have our quantum resources. So basically our quantum processing units, our QPUs, and our emulators that we can call backends. So Pascal builds their own hardware, as I just said it, and we have QPUs that are ready to use directly in the cloud, and we also develop the emulator stack. So it's basically tools which simulate our QPU and tools which are very useful for our researchers and industrial before sending real jobs to the QPU. On the other hand, so you have users, probably you very soon, or maybe you're already a user, and you want to access those resources. You can be a corporate client, an academic, a beginner, and if you want to learn how to send your first job and how a QPU is working, the quantum computing as a service product is really what you need. The cloud platform is really bridging the gap between users and those backends. It contains all the tools you need to bridge those users and those quantum resources, and it's super useful for this. It's basically a cloud-based platform whose main responsibility is to authenticate the users, validate the job, and let users monitor the job status and retrieve the results. So everything is really into one platform. It has really two main missions. The first one is that we want our users to focus on designing their quantum algorithm instead of spending time and energy figuring out how to execute it on the backend, etc. So we really try to make our tool as easy to use as possible. The second mission is really the reliability of the platform itself. As you know, quantum computing is a cutting-edge technology, so they remain quite unstable for now, and they require frequent maintenance or upgrade. The Pasqal Cloud platform itself has to remain available 24/7 for users to access their jobs and send new ones. So that's why it's here. Now let's talk about the vision. At Pascal, we really believe that real-world use case run on quantum computers, which are really going to have a business impact soon, are not far away at all. And we want users to be prepared. So until then and until today, Pasqal Cloud was an invite-only platform, but as of today, we are opening the cloud access for free, and we're opening the platform for free for everyone to be able to send jobs on a small emulator and to send your first quantum jobs on a small emulator. You will have, of course, the possibility to send jobs to the real hardware if you want to upgrade your offer. You can sign in via the link shared in the chat. So yeah, just do it if you're interested in it. Now let's talk about the offers that we have on the Pasqal Cloud platform. We have 4 offers all in all. So the Explorer, the academic one, the pay-as-you-go, and the premium. The Explorer one is the one that is going to be available as of today for free. So whether you're a developer, an enthusiast, a curious technologist, or an independent learner, and you want to explore quantum computing with minimal commitments and send your first quantum tasks, well, the Explorer offer is perfect for you. You will be able, of course, if you want to upgrade to an academic or to a premium plan, if you want more advanced features and be able to run larger simulation or benefit from additional support from the Pasqal team. We also have an academic offer. This academic offer is really targeted for PhD students, professors, postdocs, and yeah, labs working on quantum computing research in general. We today, for example, have collaboration with a lot of universities in France, of course, but also in the US, in Canada, in South Korea, in Italy, and more. So if you really want to collaborate with Pascal on quantum experiments and develop and test your own algorithm for academic research, the academic offer is really for you. We also have a pay-as-you-go offer. The pay-as-you-go offer is targeted for, let's say, autonomous users, people who want just to try out the QPU, who are developers, engineers, and who wants an immediate access to the Pasqal Cloud hardware with a familiar cloud platform. So we are integrated in the Google Cloud Marketplace and in the Azure Cloud, in your own Azure Quantum workspace, as we call it. And if you do not exactly know how much QPU time you need, well, this offer is really for you, and you will be able to experiment with algorithm in your own familiar cloud ecosystem. That's what is super interesting with this offer. We have more partners coming soon, but yeah. Yeah, to finish, we have our premium offer. So the premium offer is really for corporate users, including developers, innovation managers, or CTOs. And if you want to kickstart your company's journey and run critical workloads on a high priority QPU while receiving professional services from Pasqal, then the premium offer is really for you. You will be able to scale quantum initiatives within your company and integrate quantum workflow into production pipelines to have real business value. So yes, that's it about the offers and about the Pasqal Cloud presentation. I will leave the floor to Lucia and I will be happy to take questions a bit later.
All right, thank you so much, Baptiste. Thanks a lot for your contribution. Let's jump right at the questions. So as I mentioned before, if you have questions, please don't hesitate to share them in the questions feature. I already see a couple of them. We will have a brief Q&A session now and then one longer at the end. Let's start with the first one. Are there resources for learning quantum programming within the platform? Who would like to jump on this?
Sorry, can you repeat the question?
Yes, are there resources for learning quantum programming within the platform?
Yes, of course. So we have what we call the Pasqal Cloud community, which is a platform in itself on which you have a big, super interesting e-learning that we call Quantum Quest, that you can do to really learn and have your first steps in quantum computing itself. We also have a Slack channel in which you can interact with the community if you have any questions, etc. So it's super useful if you really want to step your first foot in quantum computing. And we also have a very detailed documentation platform that is available. I think we will put the link in the chats. If you want to try to sending your first job and really try out the open source tools that we have, everything will be there and super clear, basically, or as clear as possible, at least.
All right, then we have another question. So is Pasqal QPU free to access? I guess it's in terms of free, free.
So the QPU itself is not free to access. To the Explorer offer, you will have access to our small emulators that we call emu-free. So you will be able to simulate up to 12 qubits. And if you want to upgrade your offer and send jobs to the QPU, you will have to pay. So yeah, the answer would be no, but there are several things you can do before really using the QPU, basically.
All right, then I suggest just to keep this part a little bit shorter, as I mentioned before. So we will get to the other questions later on. Before we dive into the second part of the presentation, we have another poll question. So it will pop up in your screen. What do you see as the biggest challenge in adopting quantum computing as a service? Take the time to read the answer, and let's see what the poll says. All right, I see that there is a majority of answers saying that identifying use cases where quantum can really bring value might be a challenge, might be an issue. But I really think that Matthias' part of the presentation might even prove you wrong, or at least help you understanding that there is already value brought by quantum computing already now. So thanks a lot for participating in the poll. And now I leave the mic to Mathieu.
Thank you, Lucia. So hi, everyone. Mathieu here. So I will be presenting Pasqal Software Stack and then do a short demo of the platform. Okay, so Pasqal Software Stack is structured as a multi-layer open source ecosystem. Our goal is really to let anyone, beginners, industrial, but also quantum physics experts, to get the maximum value out of a neutral atom quantum computer. So the first layer is the quantum applications. They are ready-to-use algorithms designed to address challenging problems in mathematical optimization and machine learning. They showcase how to bring the value of hybrid classical quantum algorithm to your business or research. And you don't need any quantum expertise to get started with them. During this webinar, we will demonstrate one of our quantum applications, the Maximum Independent Set Solver, or MIS for short. MIS is a standard graph problem common in logistics, scheduling, and network design. In the general case, it's a very hard problem to solve for classical computers. And our Maximum Independent Set library leverages quantum techniques to uncover optimal solutions. These quantum applications are built on top of our quantum software development kits, or SDKs, which is the second layer. They offer to quantum physics experts very fine control to experiment with our QPUs, or even design innovative quantum applications on their own. The SDKs really help bridge the gap between theory, experimentation, and real-world quantum solutions. And finally, the final layer of the software stack is the cloud platform itself. The software development kits can seamlessly submit jobs for execution through the cloud on our QPUs or our emulators. On Pasqal Cloud, we currently host one QPU with 100 qubits, and more will be coming very soon, and as well as different GPU accelerated emulators, as mentioned Baptiste before. This enables anyone to run quantum workflows for their research from their laptop without having to set up any custom infrastructure, really. Okay, so that's a very quick overview. Let's really see what it looks like in practice. So, okay, let's look at a use case. So let's say you want to optimize the location of radio antenna for the 5G network. The goal is to provide effective mobile network coverage while minimizing costs and satisfying quality of service requirements. This problem can be modeled as a graph problem, where the nodes are candidate antenna sites, and if two antennas interfere with one another, we create an edge between the two antennas, between the two nodes. So finding the maximum independent set on this graph, this will provide a good solution for our antenna placement problem, because it guarantees that there will be no interference between our antennas while maximizing the coverage of our 5G network. And this should help us meet our quality of service requirements as well. So during this demo, we are going to use Pascal's maximum independent set library to solve the radio antenna optimization problem on a small instance. And there will be several steps. So first, we will take a quick look at Pascal's Cloud portal to get a quick overview of what it looks like and what you can do with it. Then we will jump into a notebook where we will run the MIS program on the graph. And finally, we will go back to Pascal's Cloud portal and Pulsar Studio to check what the quantum job actually looks like. Okay, so let's jump into it. So I will share my screen. Give me a minute. So at this stage, you should see my screen. Is that correct? Yes, it looks like it.
Yes.
Thank you. All right. Welcome to the user portal. This is where you will sign up, you will manage your account, and so on the Pasqal Cloud platform. So for this demo, I have already set up my account, of course. After signing up, you will be guided, but the first thing you will have to do to be able to send quantum jobs on the platform is to create a project. With the starter offer, you will be able to create an Explorer. With the Explorer offer, you will be able to create a first free project by clicking on this button. So here again for this demo, I have already set up my account with a premium project. I can check my projects from the screen. Oh, yeah.
Sorry, just didn't mean to interrupt you. Would you mind to zoom in, please? We have a request from the audience. Thanks. Thank you. I guess now it's a little bit better. Perfect. All right, good.
All right, thank you. So I have set up a premium project already on my account. We can check it out from this button here. Here is my list of projects, and we can check the details of my Cloud Webinar project, as you can see here. So the project defines a list of backends you have access to. So for example, here I have the list of emulators and QPUs that can be accessed directly from my project. It also defines the number of credits that you have, and every time you will submit a job, credits will be deducted from your account until it reaches 0. the cloud platform was designed with collaborative work in mind from the get-go. So you are able to invite your colleagues to your project by clicking on this button. And for example, here I can invite Baptiste by simply putting his email in here. I can select a role for him, and then I invite him, and this will prompt him to either accept or decline, obviously, the invitation to my project. And once he has accepted, he will be able to access all my quantum job, and this will unlock the potential of our collaborative research. Okay, so now that we have set up a project, we are ready to send some jobs, some quantum jobs on the platform. So let's go back to the dashboard here. And the dashboard is really the main screen where you will get a quick overview of all the research work. So the main component we're going to look at here is this table here. So here you get a quick overview for all of your projects of the last jobs that were submitted. So you can very quickly see what is the status of the last quantum jobs you submitted. So as you can see, I've already submitted a few test jobs before this webinar. All of them are done, and they were all targeting the MPS emulator. You also get some nice statistics if you're interested. And if your colleagues have already submitted some other jobs on your project, you will be able to see them here as well. Let's take a look at one job. So let's pick the first one here by simply clicking on it. So as you can see, it was sent on MPS, as I mentioned. You have a bunch of other information from here, and you get even more details from this screen here. So here, for example, you have some details on how long it took to execute on the backend. You get a quick visualization of the results, and so on. So, okay, so I think for now we are set. We have really touched on the basics of what the cloud platform looks like, the different types of components, so a project, a job, what this all of this looks like. So we are ready to actually run the MIS problem. Sorry. Okay. So to run the solver, we will use a Jupyter notebook, which is a very standard tool used by researchers and is industrial for local development. It lets you run code and display images in the same interface, which is very convenient. And the code for this demo is directly extracted from one of the tutorials of the MIS library. I think I will share a link for that. So you can check it out and run it yourself easily if you want. Okay, so let's go on the notebook. It should be right here. Yes, here we go. So this is a notebook. If you are a developer, you're probably a Python developer, I would say you're probably familiar with it. I hope you can see nicely. Let me maybe zoom in just one more time. Okay, so first we have some very basic instructions to import the MIS library. I won't stay longer on that. And then obviously, so what we want to do here is to solve our to figure out the best antenna placement for the 5G network. So obviously what we need is an example of a graph for which we will try to find the best locations. So here on my laptop, I have already a graph installed somewhere. So I will just import it here and we can display it like this. So as you can see, I have a 16 nodes graph with 22 edges. And what the MIS library will be able to do is to find the maximum independent set for this graph. And this will give me the best position for my antennas to maximize the coverage while minimizing interferences. Okay, so so that's what the code looks like. And here is really the interesting part. This is the part we are interested in and which will solve our MIS. Okay, so as I mentioned before, you need obviously an account on the Pasqal Cloud platform to make use of it. So I have my email that I wrote here, as well as a project ID. So this was taken directly from the cloud portal that I showed just before. Okay, once we have these, we are ready to go. We just need to configure our solver and run it. So to configure our solver, this is the code that is taking place here. The most important component is this one. So here we define which backend we're going to use to run our experiment. So here I have been targeting the MPS emulator. So MPS stands for Matrix Product Space, which is one way, which is a custom emulator, which is GPU accelerated, which was designed by Pasqal, which is very good to simulate the a QPU, basically. It's very easy to switch between the different types of backend. Here, as you can see, you have 3 examples. You can switch to the EMU3 emulator, but also to a real QPU. So note that for this demo, I sadly won't be able to submit my job to a real QPU because our QPU is being upgraded as I'm speaking. So I will run this on an emulator. The other components are simple instructions to make sure the solver runs nicely. And once our configuration is set, we're ready to go. We can simply run this simple command here, solve, which will run our MIS solver. So, okay, so I just ran this sequence here, and I am prompted to enter my password. So give me a second to find it. Okay, so now if I input my password in here, this should run. Okay, perfectly. No error messages. So far we're doing good. So what's going on here? As you can see, there is absolutely no quantum details that are exposed here. Everything is abstracted away for you, so you don't need to know anything about quantum really to be able to run our MIS library. So here, our jobs were submitted to our MUMPS emulator, and is currently being executed. So if we just wait a few minutes, we will see the result popping up, and we will see the maximum independent set for our graph. Here for this demo, I wanted to deep dive a bit more into what the quantum job actually looks like. And to do that, we're going to go back to the user portal and take a look at our job. Okay, so if we go back to the dashboard as we initially planned, sorry. Yes, okay, so we're back to the dashboard here, and as you can see, a job was just submitted to the platform, which is nice. It's indeed targeting MUMPS, and I can check the details right here. So I can click here and even here to get even more details. Okay. So you might be wondering how the MIS solver translated our graph into a set of instructions to execute on a QPU or an emulator. And we have developed a tool called Pulsar Studio, which will help us visualize the quantum job. So let's import it into Pulsar Studio. So let's import my job created by the MIS solver into Pulsar Studio by clicking on this button here on the top right. Okay. Okay, so this is Pulsar Studio. Welcome to everybody. So Pulsar Studio is a graphical interface to program a neutral atom QPU directly from your browser. To program a neutral atom QPU, there are two main components. The quantum register that we can see here on the top left. So every single green dot that you can see here represents an atom that is trapped at this specific position inside the QPU. Each atom is a qubit. So here we have a 16 qubits experiment. At the bottom, we have the laser sequence. So it defines the amplitude in purple here and the detuning in white of a laser that we will beam onto the quantum register at each time step. This laser will change the quantum state of the atoms, and at the end of the laser sequence, we will measure the final quantum state. And by repeating this operation a bunch of times, this will give us the probability of each quantum state. Okay, so this is nice, but how does this relate to solving our 5G network problem? So to sum it up, from the radio antenna possible location, we built a graph. Then the MIS solver maps the graph to a quantum register, which we can see here, and a laser sequence that we can see here. By looking at the final quantum state that will result from this quantum job, the MIS solver is enabled to identify the maximum independent set for my graph, and this maximum independent set gives us a good solution for our 5G network. Something to note here is that we imported the job from the cloud platform into Pulsar Studio. But Pulsar Studio is also a standalone tool that you can use to really define a very precise quantum experiment. So every component here is interactive. So for example, I can move atoms around, as you can see. I can add new ones. I can delete some of them if I want to. I can edit the laser sequence as I see fit, and so on. So every component here is you can interact with, and you can update easily from your browser. What's very nice about Pulsar Studio is that for small quantum registers, you can even simulate locally the dynamics. So here I am over 12 qubits, so I can't do the local simulation, but I can also submit it on our cloud emulators by simply clicking on this button here that you can see. And this will create a job that you can then see on the cloud portal, and you can download the results and so on. So thanks to that, thanks to Pulsar Studio, you can really control the quantum processor very finely and experiment and get a really good intuition about what's going on in the dynamics of our neutral atom quantum processor. Okay, so at this stage, hopefully, our job that was sent by the MIS solver should be done. So let's go back here. Okay, wonderful. Everything went smoothly. So my job, as you can see, the status is now done, and I have this nice probability distribution that is a result of the simulation. And as I mentioned before, this distribution that will be used by the MIS solver to infer the maximum independent set for our graph. So now if I head back to my notebook that is here, and I go a bit below, sorry, I don't know why there is this, okay, good. So here, this identified the maximum independent set for my graph. So the green dots here is the maximum independent set. And basically this tells me that if I put antennas at position 1, 2, 4, 9, 8, 11, and 15, and 16, I will get a good coverage for my 5G network without having any interference in between my antennas, which is what we wanted initially, which is nice. Okay, so this is basically the end of this demo now. To wrap it up, what we saw is that you can leverage Pascal's high-level quantum libraries to solve real use cases without having any real knowledge about quantum processors. And at the same time, we also took a sneak peek at Pulsar Studio, which really lets you control very precisely what's going on inside the QPU and see exactly what the effect is on the experimentation. So if you want to know more about all of this, we have a documentation portal that I think we mentioned a bit earlier that you can access online without even having an account on our platform. And I think there is a link that was shared by Andrea, thank you. And on this platform, you get a list of all the tools that we make available to our users, and you get also a bunch of tutorials to make the most out of them. So thanks a lot, everyone, for your attention. If you have any questions, please add them in the chat, and I'll be very happy to answer them at the end of this presentation. And now I will give the microphone back to Baptiste, and he will present the roadmap for Pasqal Cloud platform. Oh, so let me just stop the screen share, and we should be good to go.
Yep, amazing. Oh. So what's coming? Thank you, Mathieu. Very precise and no bug during the demo, so nice. What's next, and yeah, what's coming? So our vision is that we firmly believe that quantum computing, as I told you before, will start delivering real business value for our partners within the next 5 years. We also have an international ambition, and we offer our services for our clients all around the world. So today, the QPU we have is available on the cloud and is the one that is available in the Paris area. And the Canadian QPU is being finalized as we speak and will be available very, very soon, before the end of the month, basically. So the Canadian QPU, yes, and there will also be the Saudi Arabian QPU that will be available Q2 2026. It's originally delivered for Aramco, but some of our Middle Eastern clients will also be able to use it. When it comes to the hardware updates, so we aim to keep expanding our hardware capabilities to make our quantum computing as a service offering as complete as possible. So early 2026, there will be 140 qubits coming very soon. A bit later in the year, there will be several hundred qubits coming. And we also will have available the local addressability feature in 2026. When it comes to software features and updates, we also want to make quantum computing as easy to use as possible. That's why we are really going to keep developing our open source application suites, and that can run either locally or directly on the cloud. So the MIS that Mathieu showed is really the example of it. We also have available the KEK one, so Quantum Evolution Kernel, and other ones are coming. I saw in the chat that you were asking about some other ones, and they are coming really soon. We also strive to make the cloud experience even smoother for our users by giving better visibility on our upgrades, adding payment features, and improving our UX overall. So yeah, that's what's coming. So I think that's basically it for me. Yeah, so that was all about the quantum computing as a service offering, and I will let Lucia conclude.
All right. Thank you so much, guys. Thanks for your contribution. It was really, really interesting. I see a lot of questions and a lot of interactions in the chat. So it was a very lively webinar, I must say. And we covered quite a lot. So I would like to wrap up and focus on 3 key messages that you can bring home. So first of all, thanks to the Pasqal Cloud, you get access to neutral atom quantum computing resources as easy as any other online service. This access has become, as of today, open, so everyone can already start signing up through the link that will pop up in a second in the screen. You can start already today experimenting with neutral atom quantum computing and our solvers or libraries like MIS, as Mathieu shared. And Pasqal Cloud is, as Baptiste shared before, designed for your growth, to accompany you growing through your quantum journey. So either you are experimenting with your first quantum jobs, or already looking for enterprise ready solutions for your company, every offer can suit your needs. So feel free to join, feel free to sign up and connect with the team. All right, so now let's do the final poll of the session of today. In which state are you after this webinar? If I am honest with you, I am fully entangled. I'm really excited about what will come next and what has been unlocked through the open access program. Let's see, what is your opinion? All right, it's in a super, some people are even in a superposition state. Okay, in a stable state, met expectations. That's good to see. All right, I see people still answering, but the stable state definitely win over the other states. So good job, guys. All right, so it's now time for your questions. So first of all, there are many many questions, so we will have to pick probably some of them, and in case we don't manage to answer all of them, we will get back to you guys. So first of all, how many QPUs are available through Pasqal Cloud?
So yeah, we have the one that is available on the cloud today in the Paris area. So one, the Canadian QPU that is coming really soon, and then we'll have the Saudi Arabian one, Q2 2026. So 3 in 2026, for now, almost 2, let's say.
All right, good. Thanks, Baptiste. Another one regarding access. So how is emulator access managed? Is it credit-based like the QPU usage?
You want to take this one?
Yeah, sure. So yeah, for emulators, so as we mentioned for the Explorer offer, the emulator EMU3 is free to use. However, you have some limitations to make sure that you do not spam our emulators too much, of course. But then for the other offers and the more advanced emulators, typically the GPU accelerated emulators such as EMU-MPS, then the usage is tracked by hours or shots, just like for the regular QPU, basically. So, and it depends basically on the type of offer you selected and the type of emulator you are using.
All right, then as always in terms of emulators, are emulators reproducing also the noise from real quantum devices?
Yeah, this is a really interesting question. So that's something we are actively working on and which is available right now. It's a very new feature I think we added recently. But yeah, short answer is yes. So basically, from Pulsar, which is the main library you're going to use to be able to submit your quantum job and define them, you are also able to define your noise model, and this noise model will be used by the emulator to impact the simulation and to so that it acts like a real QPU. The QPU noise model is also available through the cloud platform, so you can submit the noise model you receive from the QPU to use it on the emulator, so that your emulator really behaves like a regular QPU. I think there is some sources of noise which are not entirely supported yet, but we are, of course, actively working on them all the time to make sure you get everything you need.
Good. Thanks, Mathieu, for the answers. Another one. So Pasqal Studio, does Pasqal Studio have limitation in terms of qubit numbers?
So yeah, Pulsar Studio is, so that's a good question. So you can simulate directly through your browser up to 12 qubits. However, as Mathieu showed you, you have also the cloud emulation tab, and through the cloud emulation tab, you can send job through the MPS, so basically the big emulator. So for this one, you're not restricted. But about what you can simulate directly on the border and directly through Pulsar Studio without having to go through the cloud, it's up to 12 qubits.
All right. Then let me see. May I know if Friedberg.local is made available for all qubits in the available QPU via the cloud?
So I take this one. This is something that is mentioned on the roadmap. So currently there is no addressability feature on our QPU, which would let you address, target a specific QPU. So answer is no for that. Our emulators are, however, able to, I think our EMU3 and QTIP emulator are able to simulate these kind of channels. So you can use that if you're interested in the meantime.
Okay, all right. Then I also, so there are many questions I see that are related to quantum and AI or quantum for AI. We will not manage to go through all the details of these questions right now. I would suggest I will share in the chat with everyone a link to a white paper that we wrote for quantum and AI. You can start taking a look there, and we will get back to you with more specific answers to your own questions. Sorry about that, but we are running a bit out of time. So do you see the link that I shared in the chat? Please let me know. All right. Then in the meantime, I have another one, if you guys are still fine with answering questions. So does the emulator give an estimation of the time to run the process it was given as if it ran with QPUs?
So I'm not entirely sure. So note that most emulators that are available on the cloud platform are open source. So you are able to access the code directly. I think there is some white papers on the performance and some benchmarks that are available for these emulators. So I would probably refer to these. But for very specific experiments, that's something we are actively working on, but it's a very difficult task. So unfortunately, we don't have any clear estimations right now for emulator jobs.
It's vague, let's say.
Yeah, for QPU, it's much more predictable. Basically, we are able to estimate the repetition rate of the QPU much easier. It's much easier to do. And it's basically, it depends on the number of qubits. So for this, we are able to give you a good estimation of how long your job will take.
All right, thank you, Mathieu. I see that one of the questions is about how, as researchers, you can contribute, and if I will answer to this one. First of all, it would be great to have all of you connecting with our community Slack. It's a workspace where we share knowledge, but also we launch projects where so you can collaborate with Pasqal on our open source projects. We, for example, provide access for beta testing our solvers, like, for example, MIS was beta tested by our community. So I would say that the first step could be to join the community Slack. It will, so the link will pop up in a second, and already from the chat you can start using the questions and support channel that and you can ask for collaborations and ask for common projects. And as Baptiste mentioned, using the academic offer, you can already start collaborating with Pasqal about applications as well. So not only developing code. I don't know if Baptiste and Mathieu wants to add anything on top.
Yeah, you can. No, not really. You can just contact us to the request access page on the offer page. So I'm going to link it in the chat, and yeah, we will answer you if you need the access or define your use case, and we might help you. So yeah, don't hesitate to reach out.
All right, good. Then let me see. We have really so many questions. I'm sorry. We will need to prioritize a bit because we are running out of time. Let me take a look.
So maybe a question about use cases in general, and especially in the fashion industry. That's interesting. The thing is, like, in every industry, you are going to have problems that can be solved on quantum computers. So if you're in the fashion industry, you're going to have a lot of logistic problem. You can even have a material simulation problem, and we can help for those. So yeah, every industries could really be impacted, and we will help you doing so.
Perfect. And if I can also add on top of this, I'm just looking for a link. Sorry about keeping you waiting. I think it's also a cool resource to take a look at the success stories that we have on our website. I'm sharing the link right now in the chat. You will see that, as Baptiste said, a lot of industries are already benefiting from our tools. So you can have a clear overview of which are the industries that can be impacted, let's say. All right, good. Then as time is really running, I suggest we move to the next step, which is, as I mentioned before, the presentation of our Pasqal community. So we do have a community platform, as Baptiste mentioned, where you can access learning resources, Quantum Quest, but also connect with us and among the other users. You can connect through Slack, and you will be up to date with all the product updates, but also with the upcoming webinars in the near future. And as I mentioned before, collaborate with us. So then I think we arrived at the end of the webinar. It was a really exciting one, and I really would like to thank all of you for being so engaged and so present in the webinar. Thanks again to the speakers. We will get back to all the questions that were unanswered. Sorry about that, but as we would like to keep going with the webinars and we want to learn from the experience of today, we would love to hear your feedback. So here you can see a link to a very quick survey, just 2 minutes of your time, but we would really appreciate your help to improve for the next one. All right, Good. So thanks again, everyone, and
Thank you.
thanks the speaker. Good, great. And see you in the next webinar and in the community. Have fun with the cloud. Bye.
Thank you guys. Thank you.
Bye. Thank
Thank
you.
you, everyone.